Welcome to Class TV. I read myself Alewitosin. Now we are taking range under projectile. Now we say what is range? We say range is the what? Is the horizontal distance, covered by a projectile from the point of projection to the point where it returns to what? The same level on a projectile plane. When the projectile moves this way, it covers a what? A distance. Now we note that there is a relationship between the angle of projection to the what? There's a relationship between the angle of projection and the what? Horizontal distance covered by the what? Projectile. Now let's derive the formula for calculating what? The range of a projectile. Now, from Newton's equation of motion, we said that what? S is equals to ut plus half at square. Okay? Now, under gravity, it means that our S will be h, and we are having u plus or minus 1/2 gt square. Now we need to note this, that this is horizontal distance, which means that what? We are not considering the what? We are not considering the vertical component. We are only considering the what? The horizontal component. Now considering the horizontal component, it means that what? Our g is equal to 0 because gravity is not considered. And again, recall that we said that what? Our horizontal component ux in this case will be equal to u cos what? Theta. That's our horizontal component. So which means that from this equation now, we should be having h, right? Now, so far we are looking for a range now, which is what? Horizontal component. Instead of having our h here, we'll be having it as r, which is the horizontal distance. Horizontal what? Distance, which is horizontal distance, and we're having ut. Our u now will be u cos what? Theta, and this t, where all this, which is plus or minus 1/2, our g is what? Our g is 0, t square. When you multiply everything here by 0, they all disappear. So you're having this left. You're having r is equals to u cos theta. Now, note this t that is here. Remember that we said it that this is the time taken for a body to reach its maximum height, which is the time taken to get for a projectile to get to this point. But for range now, we are considering the time taken for it to move and come back to this point. So the time taken we should be applying here now should be time taken for what? That's time of flight. It should be the time of flight. I think let's also change this to, it should be the time of what? Time of flight. Now, why it is the time of flight now? We can now recall. Let's call this equation 1. We can recall that we said it. Recall that we said our time of flight is equals to 2u sin theta over g. We explained this in our video where we talk about time of flight. Now, which means that if we solve for this in this formula now, so it means we'll be having now that our r, which is the range, is equals to u cos theta bracket 2u sine theta over g. Now this means you're having something of this form: u times u square, then you're having 2 sine theta cos theta over g. Now we have to recall for something under trig identity. Under trig identity for double angles, we said that what? Under trig identity for double angle, there is a formula which says that sine 2 theta is equals to what? 2 sine theta okay, 2 sine theta cos what? Cos theta. Sine 2 theta equal to 2 sine theta cos theta. So with this now, we can solve for this, right? We can solve for this now in this, saying that our r will now be equal to u square. This 2 sine theta cos theta now will be replaced with this, because this gives this, so that we have what? This will be sine 2 theta over g, and that gives us a formula for what? That gives us a formula for what? For range of a what? Of a projectile. Formula for range of a projectile. Now let's try to see if we can decide our maximum range, because for this now, your maximum range here is an angle where the highest angle, the angle you can attain, where you have the maximum range. The angle you can attain where you have your maximum range. Now that angle where your projectile can be positioned, for you to have a maximum range in your projection, the angle is what? 45 degrees. You can have your maximum range. That means you can, when you set your target, your catapult to what? To angle 45 degrees. It is proven that what you have your maximum range. Now for maximum range, and we denote maximum range by R max. Now if your maximum range is denoted by R max, right? Let me just manage that side. It's denoted by R max. Then we can say that what? U sine 2 theta will be equal to over g. Now where our theta is 45, where your theta is 45 degrees. This is a past question in y, so please let's take note of it. So we are saying that it means we are having our R max now will be equal to u square sine 245, that's 2 times 45 over what? Over g. So your R max here now will be equal to u square sine 90 over g. Now note that sine 90 is what? Is 1. You can press the calculator for that. Sine 90 is 1. So you say that your R max is equal to what? U square over g. That's the formula for what? For maximum range. Formula of maximum range is what? Is u square over g. Square over g. So we take question in our next class. Thank you.